Let's continue with the in-text questions, or rather answering the in-text questions, that is. So we need to derive the structure of the compounds from the given IUPAC names. Now the easiest way to do that, or the way that I would prefer if you do that, is if first we know that the compound will consist of a prefix, a word root, as well as a suffix. So the word root will give us the information about the number of carbon atoms which are present. So from there, and so first write down the structure from the word root and then add in all the addition, whatever functional groups or side chains are present in the compound. So the first one is 2-chlorohexane. Now, first of all, hexane. Hexane consists of 6 carbon atoms. So, first let's write down 6 carbon atoms. CH3, 1, 2, 3, 4, 5, and 6. Now, 2-chloro means that at the second position, we have a chlorine group. So it can either be this carbon or this carbon. Both of them are right. So if we write it at this carbon, numbering is going to be 1, 2, 3, 4. Whereas if we write it for this carbon, numbering is going to start from here and it's going to be 1, 2, 3, 4. So here we will just erase the 2 because it has to maintain tetravalency. Right? Cl. So CH3, CH, 1, 2, 3 and 4. The tetravalency of carbon is maintained. Next, pent-4-ene, 2-ol. So pent-4-ene. From here, pentane. We know that it's a pentane straight chain. So let's first write down the carbon atoms. CH3, CH2, 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 CH3. Now at the fourth position there is an alkene, okay, and at the second position there's an alcohol. So first let's go to the alkene. 1, 2, 3, 4, right? So if this does not mean that we will be putting a double bond here, because number 4 implies that the double bond is between the fourth and the fifth carbon atom. So the double bond comes here, CH2 gets erased, the 2 gets erased rather, and so does this 3. And this is erased to give us 2. And at the second position we have an alcohol group, so 1, 2. So here we have an alcohol, OH. Next, 3-nitrocyclohexene. First of all, this is a cyclohexene ring. So let's draw cyclohexene. Now, according to what we've learned up till now, according to that, the double bond in the cycle should have the lowest pair of locants, that is 1 and 2. It has to be, the double bond is going to be between numbers 1 and 2. So you can write it 1, 2 and 3, and at the third position you can put a nitrobenzene, or even if you write 1, 2 and 3 and nitro group, even then it is right. Here I put 1, 2 and 3, and so NO2. This is 3-nitrocyclohexene. Between 1 and second position there has to be, according to the rule that we've learned, that the double bond has to be between the lowest pair of locants, that is 1 and 2. And at the third position you have a nitro group. Now this can also mean 1, 2 and 3, and this would have been the NO2 group there. Next, cyclohex-2-ene 1-ol. So we know it's a cyclohexene ring. So it is, the cyclohexene ring has an alcohol group, and so alcohol gets more, it has more priority. So let's write the alcohol here. So it is the first carbon, first, second and third. So here we could either first write the alcohol group and then fill in the double bond, or the other way around. We need to make sure that the alcohol is at the first position while the double bond is at the second carbon. Now hydroxyheptanol. So heptanol has 7 carbon atoms. So first let's write that CH3, 1, 2, 3, 4, 5, 6 and 7. So there are 7 carbon atoms in heptane. Now at the 6th position there is a hydroxy group, and hydroxy group means it's an OH. So 1, 2, 3, 4, 5 and 6. So at this position there is an OH group. Now remember, between an aldehyde and an alcohol is going to get less priority than the aldehyde. An aldehyde is basically a CHO. So this carbon, the first carbon, is actually a aldehydic group. Now if suppose we had the CHO on this side, then the alcohol would have been the second carbon. Next, we have to write the structure of the following continuation 12.10 orthoethyl anisole. So the anisole is basically a benzene ring. It has a benzene ring. One second. Okay, I know why it's happening. Okay, anisole is a benzene ring with an OCH3 group. OME or OCH3. Now ortho, meta, para, ortho, meta and para positions. So orthoethyl means over here at the ortho position there is a C2H5 group which is present. Now this C2H5 could have also been on this side, that is also an ortho position to the OME. Next, para-nitroaniline. So the para position, first of all, this is an aniline ring, which means it has an NH2. So NH2, and at the para position it has an NO2. So there are no other positions which are possible for this structure. Next, dibromophenylpentane. Now this means that there is a pentane ring, pentane straight chain. So methane, ethane, propane, butane and pentane. Methane, ethane, propane, butane, pentane. So 5 carbon atoms basically. At the first position you will have a phenyl ring. So this basically means that the first carbon is bound to a benzene ring. Okay, so this is the first carbon atom, second, third, fourth and fifth. So at the second and the third position we have bromine. So this is the structure of the compound. So we have a phenyl group at the first carbon and then bromine at carbon number 2 and 3. The last one, 4-ethyl, 1-fluoro, 2-nitrobenzene. So I'll just draw it here. So first let's draw nitrobenzene. So this is benzene, this is the benzene ring, okay, and this is the nitrobenzene. Now according to this, the nitro group is at the second carbon. So assuming this is the second carbon, this would be the first, or you can take this as the first. Either of them can be the first. So I'm taking this as the first carbon. So 1, 2, 3 and 4. So here you will have the ethyl group. So what and we can't number it as 1, 2, 3, 4. No, we have numbered it in such a way that nitrogen NO2 is having the second position, fluoro has the first position, C2H5 has the fourth position. So we first drew nitrobenzene and then filled in the other groups. With that, we're done with the in-text questions. Next we will be learning about isomerism, so do check it out.